Good morning, all of you. This is Sham, Assistant Professor, Civil Department in Chevron Engineering College. Subject Estimation, Specifications and Contracts. Unit 3, Earthworks for the Roads and Canals. On topic Earthwork Estimation Problems. So we will discuss already types of earthworks, different methods used to calculate the volume or quantity in earthworks. So first one is the mid-sectional area method, second one is the mean sectional area method, and third one is the trapezoidal formula method, and fourth one is prismoidal formula method. So first we discuss the problems on mid-sectional area method. So write the problem. Reduced levels of ground along the center line of a proposed road from distance 200 meters from the beginning to the 500 meters distance are given below. The formation level at 200 meters distance is 127 and has a falling gradient of 1 in 150 up to 320 meters distance mark. Thereafter, the falling gradient changes to 1 in 100. Formation width of road is 10 meters and side shape is means side slope. Side shape is 2:1. Draw the longitudinal section of the road and typical cross section and prepare the estimation of the earthwork at rate of 900 per 10 cubic meters. Interval of levels being 30 meters. Also find out the area of the side slopes and cost of the turfing the side slope at the rate of 150 per 100 square meters. So draw the table form. Distance in meters 200, 230, 260, 290, 320, 350, 380, 410, 440, 470, 500. And RL of the ground 125, 125.60, 125.44, 125.90, 125.42, 124.30, 125, 124.10, 124.62, 124.0, 123.30. It is the final value RL of ground. So firstly write the problem. So first here, what is the given data? So first of all, the central line of the proposed road from the distance 200 meters from the beginning to the end. So here distance is given 200 meters to 500 meters, means change is 200 distance in meter, 200 to 500. Any given below, the formation level 200 meters at a distance is 127. It is the formation level 127 at 200 meters. And as the falling gradient is 1 in 150 up to 320, means up to 320, 150 gradient, and remaining after the falling gradient is 1 in 100. This portion is 1 in 100. So this portion is 1:150 and 1 in 100. This portion 352, remaining 500. This is the 1 in 150 is the 320 to 230. First value is the given RL formation is 127. Okay, clearly. Next one, Formation width of roads is 10 meters. Formation width is 10 meters. And side slope is 2:1. Here we find the draw the longitudinal section. Means x-axis, y-axis. And prepare the estimation of the earthwork rate is 900 per 10 cubic meters. It is the cubic meters in central portions. I also find out the area of the side slopes and the cutting of the turfing is 150 rupees per 100 square meters. Sorry for the distance. So side slopes 150 per 100 square meters. Okay, clear? We go to the solution. So this is the longitudinal section. This is the table form. Distance in meters, RL of the ground, RL of formation, height of the embankment. Here depth of cutting is the filling, it is the cutting portion. We find out totally in filling portion is come. No depth of cutting. It is the datum line and it is the y-axis, it is the x-axis. It is the formation of the RL of line. This is formation line. This is the RL of ground levels, RLs. So first one, distance in meters, right? 200, this table form, distance in meters, 200, 230, 260, 290, 320, 350, 380, 410, 440, 470, 500. This is in given data, total distances. And each chainage is 30 meters. 230 minus 230, 260 minus 230, and each chainage is 30 meters. And next one, RL of ground. This is also given data table form. RL of ground is 125, 125.60 and up to 123.30. This is the RL of the ground. Next one, RL of formation. This is the values are we find out in from gradients. First one at 200 chainage, RL of formation is 127. This is given data. At 200 meters, distance is 127. This is the formation level. Clearly? So it is the 127. Next RL of formation. Here up to 320. Gradient is 1 in 150. This is 320 gradient. So 1 in 150 and 1 in 100. These are two gradients. So you find out value 30 divided by 150. That equal to 0.20 and 30 by 100 0.3. So add the RL formation. 0.20 is less, 127 minus 0.2, 126.80 and less 0.2, 0.60. So in this 127 minus 0.2. Okay, next 126.80 minus 2, that is 126.60. Next one, this is minus 2. 126.40, next minus 0.2, 136.20. It is the falling of gradient 1:150 up to. Next is the gradient 120 and 1 in 100. So 30 by 100. This is equal to 0.3. So 125 here, this in value less than 0.3. So 126.20 minus 0.3, then equal to 125.90. Next minus 0.3, 125.90 minus 0.3, that equal to 125.60. Next one less 0.3, 125.30. Next one 125. Next one 124.70. Next one 124.40. It is totally 0.3 less in this gradient 1:100. In this gradient less 0.2. So these values are all RLF formation. So RLF ground is here 125. Next one 125.60. It is the 125.44. Next 125.90. So next one 125.42. So lines target direct take into from values. How to for this done? No confuse for this lines draw. So starting this point to end point, both the adding datum line to remaining values for the longitudinal section. So for next one, height of the embankment means heights of the embankments. This is the height of the embankments we calculated. Means filling portion. So RLF formation minus RLF ground. This is the formation line. This line minus RLF ground values is less than remaining values is the filling portion. So 127 minus 125, that is equal to. So it is the 2. Next one 126.80 minus 125.60. It is the 1.2. Next 126.60 minus 125.44. It is the 1.10. And 126.40 minus 125.90, that is equal to 0.50. Next one is the 126. So here take the round figure value or taking exact value. It is 1516. So next one 126.20 minus 125.40. This is equal to 0.78. Next 125.90 minus 124.30. That is equal to 1.60. Next one 125.60 minus 125, that is equal to 0.60. Next 125.30 minus 124.10, 1.20. Next 125 minus 124.62, that is equal to 1.38. Next one 124.70, 124, that is equal to 0.70. Next 124.40 minus 123.30, that is equal to 1.1. This is the filling portion, means height of the embankment. So next one, cross section CS. So formation width of road is 10. This is the 10. And side slopes are 2:1. This is the depths are we find out embankment heights. This is the ground level. Next we go to the table form. So table form, write the distance, height or depth, mean height, central area, sites area, total area, length between the stations, earthworks. So here this is the 1.16 coming. 126 minus 60 minus 125.44. So substitute distance in meters. Distance in meters, first value 200, 230 up to 500. So 200 to 500, it is the distances. Next one, mean heights, we calculated height of the embankment to 1.2, 1.16, 0.50, 0.78 up to 1.10. This is the mean heights or depth heights, and we calculate the mean heights. Height or depth, it is the D. It is the mean height dm. So mean height means 2 lengths is taken divided by 2. So it is the 2 plus 1.2 divided by 2, that is the 1.6. Next one, 1.2 plus 1.16, then 1.18. Next 1.16 plus 0.5, 0.83. Next 0.50 plus 0.70, 0.64. This is the taking averages. All for mean depth, final value is the 0.70 plus 1.10, that is the 0.90. It is the mean depth. Next one, central area. So central area means rectangular portion, this portion. So formula is the B into dm. This is this area for the find area. So B is the base 10 and it is the mean depth. And each station distance is 30 meters. Is the length between the stations. So next one, we calculate the area. B into D. So here we find the area. It is not L, only BDM. It is a meter square, area square. Only BDM, B into DM. So here mean depth area B is the 12 meters. Sorry, it is the 12 meters. And is also problem in 12 meters, right? So here central area for B into D. B is the 12 meters into mean depth height DM. This is DM 1.62, that equal to 19.20. Next one 1.18 into 12, 14.16. Next one 0.83 into 12, 9.96. Next 0.64 into 12, 7.68. Next one 1.19 into 12, 14.28. Next one 0.90, 1.10 into 12, 13.20. Next one 0.90 into 12, 10.80. Next one 0.90 into 12, 9.48. 0.54 into 12, 6.48. 0.90 into 12, 10.80. This is the central area of the portion. Next one side square, SD square. S value is the 2:1 slope. In this given problem 2:1. So S is taken 2. S into D square is the mean depth 1.6 square. So 1.6 square into 2, 5.12. 1.1 square into 2, 2.78. This is up to 0.9 square into 2, last one, that is value 1.68. Okay, clearly. Next one, total area BD plus ST square. So BDM plus SDM square. So it is the total area. So 19.2 plus 5.12, that equal 24.32, and 14.16 plus 2.78, that equal to 16.94. Next 9.96 plus 1.38, that equal 11.34. Next one 3.80 plus 7.68 plus 0.82, that equal to 8.50. Next one 14.28 plus 2.3, that equal 16.66. Next one 13.20 plus 2.42, that equal 15.62. Next one 10.80 plus 1.62, that equal to 12.42. Next one 9.48 plus 1.25 plus, that equal 10.73. 6.48 plus 0.58, that equal 7.06. Next final value is the 10.80 plus 1.68, that equal to 12.48. This is the total area, and length between the station is 30. 200, 230 minus 200, that is 30. 260 minus 230, that equal 30. Every chainage distance is 30. Next one, banking means volume formula, area into length. Area is the BD plus ST square into L. Area is this is the area 24.32 into length is 30. So multiply, then 729.60. Next 16.90 into 30, 508.20. Next one up to 12.48 into 30, 374.40. These values all adding. Then total quantity. Total quantity is 4082.1 cubic meter is the quantity. But we find out the amount also. So it is the abstract of estimate cost for earthwork item number, particular item quantity, unit rate per quantity and amount. So here is the only earthwork quantity is 4082.10. Substitute and unit amount is in given. So unit is 10 cubic meter for 900. So 10 cubic meter 900 rupees in percentage of cubic meter. So total cost of the for 4082.10, 36,738 rupees means 36,738.90 rupees. It is the cost, and add 5% of contingencies and work charge establishment and 1836, and total value is the 85,000. 38,575.85. $38,575.85. Next one, calculation for the area slopes S equal to square root of S square plus 1, that equal to 2.236. Next, go to the table form for the side slopes, distance, height or depth, mean height, side sloping breadth of the side slope, d into root of S square plus 1, and length, area both scale slopes 2L into d root of S square into d. So distance is 200 to 500 up to. Next one, heights we calculate 2 to 1.10 is given and calculated. So mean height is the 2 plus 1.20, that equal to 1.60. Next one, 1.20 plus 1.16, that is equal to 1.18. So it is the mean height depth up to 500, 0.70 plus 1.10, that equal to 0.90. Next one, sloping breadth of the slopes S square 1. So d value, mean depth of the slopes S square plus 1, that equal to 2.236, 2 square plus 1, 5. So multiply 3.58, 1.16, 1.60 into 2.236. So multiply with this value, all depth value, then final value 0.90 into 2.236, that equal to 2.01. And length each station is 30. So total 30 length, and area of the both side scales. This is the volume L into area and both sides. So multiply with 2. So 3.58 into 30 into 2 both sides, that equal to 214.80. Same similarly up to n value 2.01 into 30 into 2, that equal 120.60. Total is the 1297.80. Here square meters, and the amount is square meters also. Turfing of side slopes 150 per 100 square meters. Add, so amount is 946.70. Next one is the add 5% contingent charged 97 rupees. Total amount is 2044 rupees. Okay, clearly. So these are the mid-sectional area methods. Next, we go to the quantity survey in earthwork calculation for an embankment using mean area method. So this is the second method. Write the problem, work out the quantity of the earthwork for an embankment 150 meters long and 10 meters wide at the top. Side slopes is 2:1 and depths are each 30 meters interval 0.60, 1.2, 1.4, 1.6, 1.4 and 1.6 meters. So in this problems only asked in this method to solve, asked, then we solve that method. You don't ask any method, our choice, we solve any method, mid-sectional method or mean area method or trapezoidal, prismoid, or that is the our choice. So then asked any method, so solve that method. So here it is the mean sectional area method. Here given the data, embankment is 150 meters long and 10 meters width of the top. Side slopes are 2:1. So total length is the 150 meters and width is 10 meters and side slopes are 2:1 and depths at 30 meters interval, each interval at each 30 meters 0.60, 1.2, 1.4, 1.6, 1.4 and 1.6. So it is the diagram. Earth surfaces. This is the side slopes 2:1. This is the rectangular portion. This is the triangular portion. Top width is 10 meters and DR different each station, each interval. This is all the side slope 2:1. This is the base width 30 meters and length is 150 meters. So it is the mean area method table form. Here only calculate the earthwork quantity, not a longitudinal section. Only table form we calculate the quantity. Here base is the 10 meters and side slope 2:1. It is the cross section. So stations are 0, 30, 60, 90, 120, 150. So 1, 2, 3, 4, 5, 6. How to give the stations? So here intervals are 1, 2, 3. So intervals are 1, 2, 3, 4, 5, 6. So embankment length is 150. Take in 150 and 0 is starting. Each interval is divided to 30 meters. 30, 60, 90, 120. So understand here each interval is 30 meters. Here 150 total length. Okay, clear? So table form is the station depth, center area, B into D, area of the sides, so total area. Here calculate mean area. Mid sectional method is calculated mean depth. Here calculated mean area. The mean mid sectional method is calculated depth mean. Here mean area method is calculated mean area. And interval length, quantity, cutting or filling. Next one. So depths are write down starting 0, 0.60, right? And second one is 1.2. Next one 1.4. Next 1.6, 1.4, 1.6. Clearly. Next center of the area B into D. Here center of the portion, rectangular portion B into D. B value is the 10 and D value is the 0.6 into 10, 6. Next one 1.2 into 10, 12. Next 1.4 into 10, 14. 1.6 into 16. 1.4 into 10, 14. 1.6 into 16. This is the center of the area. Next one, area of the sides. So SD square. S value is the 2. 2 into 0.6 means 0.6 square. That equal to 0.72. Next one 1.2 square into 2. 2.88. Clearly side square, area of the side square. Next one 3.90. Next one 5.12. Next one 3.92. Next one 1.6 square into 2, 5.12. Okay, clearly. Next total area. Total area formula BD plus ST square. So this is the BD center of the area. Next one ST square. 6 plus 0.72 that equal to 6.72. 12 plus 2.8 that is equal to 14.88. Next one 14 plus 3.92 17.92. Next one 16.16 plus 5.12 21.12. 14 plus 3.92 that equals 17.92. 16 plus 5.12 that equals 21.12. Next one mean area. Mean area means two areas divided by 2. This is 6.72 plus 14.88 divided by 2 that equal to 10.80. Next one second one 14.88 plus 17.92 divided by 2 that equal to 16.14. Last up to last value 7.92 plus 21.12 that equal to 19.52. Next one, interval is the each station is interval 0 to 30, 30. Next one, 30 to 60 interval 30 meters. This is the intervals. So here either cutting or filling, you don't know. So you need cutting or filling. First of all, filling portion is fill. So area is BD into SD square, total area into length. So 14.88 into interval 30, that equal 324. Next one, 17.92 into 30, 492 up to 21.12 into 30, that equal 585.6. Next one, add the total area or volume or quantity, that equal 2572.8. This is the mean sectional area method. So previous case is the mid sectional, taking mean value in depth. Here mean area method in taking mean value in areas. So that is the difference in mean and mid sections. Okay, clearly all of you? Okay, thank you very much. Any doubt, ask in this session. Okay, thank you.